Miss Silverfish had the confidence working this.
So for 5.10 in your notes, I didn't really know what to say, so I just put some graphs, and then I've actually found one more that I want to talk about that's not in your notes, but whatever you feel like you should write down for this section, you write down, okay? I'm recording so that you can look at it later, and I have put another video from somebody else on It's Learning that you might find better than me. I don't know. We'll see. Okay, so this first energy profile, I may or may not have shown this before to you. There's a couple things I want to point out. Whenever it's just a single step for an energy profile, you're only going to see one hump. Okay, so that is a key to know, that if you only see one hump, that means it's a single step reaction. So like what we were working on 5.9, they would not have one hump on their energy profile because they have multiple steps, so they need multiple humps. We're going to see that in a second, okay? I think this is a question, we might have talked about this before. I mean, I questioned you on it, and most people got it right. But no, when you have a catalyst, the catalyst lowers the activation energy. So remember that EA stands for activation energy. So on the energy profile, when you have a catalyst, it lowers the amount of energy needed. So on the graph, what it does is it just lowers the hump. So maybe on a quiz, I might have you draw a new hump based on how a catalyst is used. And you put one lower. Yes?
Does it raise or keep the same, like...
The rate?
Yes.
The rate of reaction, it speeds up the rate of reaction, a catalyst. But it speeds it up because it lowers.
Lower temperature at the same temperature as the first one, it'd be
Yes, it would be. Yeah, it would speed up how fast it produces. Yes. Some other things. Make sure that you know that the reactants are on the first part, and then after you get through the hump, what's left over here are the products. Okay. Then the last bit of information is this delta H, which we technically haven't talked about this year, but we did talk about in Chemistry 1. H stands for the enthalpy, which this is the change in heat or energy or enthalpy, any of those words fit, of the reaction. RXN stands for reaction, okay? So you should know if it's endothermic or exothermic based on if it's a positive or a negative number, right? Negative means, which one? Exothermic. So a negative change in energy means it's exothermic. A positive change in energy means that it is endothermic. The way that you see that on the energy profile, if this is the change from the reactant's energy starting point to the product's ending point, if the products are higher, did it gain energy or did it lose energy? It gained. So if the products are higher, then it is endothermic. And if the products are lower, then it would be exothermic. So this graph is showing you endothermic because the product's height on the energy y-axis is higher than the reactant's starting point. Okay. Then there are some other, you can always put like, sometimes you might see the actual reactants that like the molecules be written in where you go. And then also at the top, we talked about this earlier in this unit, is the transition state. And that's where, like if you're colliding your molecules together, it's something that's not technically known what it is, but we can guess what it is. And usually when they collide, all of the molecule or all of the atoms will momentarily stick together before they break apart either unchanged, or when they stick together, then they will start to change, and then the bonds will be broken and new bonds will be formed to make the new products. So the transition state is that activated complex point, okay? So when it's a multi-step reaction, then you have multiple humps. So this shows multi-step. This is actually a two-step because there are two humps. So if you had 3 humps, I would be like, how many steps is this? And you would say 3, kind of thing. So you have two different transition states now. Where the dip is, that is telling you your intermediate. So in addition to telling you how many steps there are, the number of dips tells you the number of intermediates there are in a series of the rate mechanism. There also can be changes for the activation energies. So I have another graph, this is not in your notes, but I found this one, where it shows where the slow step is and where the fast step is. So whichever transition state hump is higher, that tells you which step is the rate determining step. So the higher the hump for a multi-step thing, that tells you the activation energy, that if the activation energy is higher, then that means that that is the activation energy that's required to overcome. And so that would be your slow step. So for the first graph, that's telling us that the first step in the series is the slow step because the first hump is larger, higher up from the reactants. And then for the second reaction that's in the second B picture, that the second step is higher. So then that tells you that the second step is the rate determining step. Okay? So this is all just kind of information that you can gather from these energy profiles. Okay? You might need to just read some. You might need to draw one. I think on the packet for this section of homework problems, I think I have you draw one. And it's all relative unless you know exact numbers and you actually have a scale on your graphing. But let's do this really quickly. It's just labeling where everything is so that we know how to identify everything. So which point, or what would we call this point right here? The activation energy. I'm going to put EA because it's shorter for me to fill in. Okay, and then what would we call this point down here? That would be the starting materials. I don't know why they call it that. But starting materials or reactants. Okay, so we did that one, Then at the top, we have two transition states. We have a non-limiting and the rate limiting. Which one do you think will be the rate limiting? The taller one, yeah. The taller one will be the rate limiting because that's telling us that that is the rate determining step. I'm going to just put TS for transition state. And then put the non-limiting TS for that hump right there. Then the divot is the intermediates. And then this one over here to the farthest right, lowest, would be the products. And then the last distance, this right here, why does it keep doing that, is the enthalpy change. Okay, so that video that I linked on It's Learning, and I will try to add some more for this whole unit, getting ready for the test next week. He goes through that, like, you're given some information and he actually has just a blank chart and he draws it. And so he talks about, and how would it change if you change this part of it. And so it's a good little, like, 10-minute video to watch if you need more help on this. Okay.